All right, so when limits fail to exist, there are three reasons why they fail to exist. So the first one is that the f of x approaches a different number from the right side of c than it approaches from the left side of c. So if you, an example of that, if you have a graph that has a break in it, so maybe it comes across and then it has a hole here, and then it comes up and starts again up here and goes across. So there's a break in it. So let's say this is 1 and -1. So as I approach, we'll just put some numbers to this. Let's say this is 2. So as I approach the x value 2 coming from the right, what is the limit? Okay, so coming from the right, what is the y value that I get as I approach an x value of 2? So the limit is 1 coming from the right. Okay, but then coming from the left, as I approach x equals 2, what's the limit there? -1. Okay, so coming from, if the limit is different coming from the right than it is coming from the left, then we would say that the limit at that point does not exist. Okay, so the way that we would write that is the limit as x approaches 2 from the right equals 1 of f of x. Sorry, I forgot to put f of x in there. Equals 1. But the limit as x approaches 2 from the left of f of x is equal to -1. The y value there is -1. So since these are not the same, that means that the limit as x approaches 2 of f of x does not exist. Does that make sense? All right. The second reason that it might not exist is that the function increases or decreases without bound as it approaches c. Okay, so an example of that, if you have a function and it has a vertical asymptote, so let's say there's a vertical asymptote here, and my function increases without bound. Okay, so if it increases without bound, then, and let's say this is 5, then we would say the limit as x approaches 5 of f of x does not exist. Because I could say, well, coming from the right side, it's approaching a y value of 100. And coming from the left side, it's approaching a y value of 100. But then it keeps getting closer and closer and closer. As it gets closer and closer and closer to 5, that value just skyrockets. It goes up to infinity. Okay? So we would say that limit does not exist. And then the third reason is if a function oscillates between two fixed values as x approaches c. So examples of that would be like sine and cosine functions, inverse sine and cosine functions. So if you have a graph that looks like this, well, if you have a graph that comes and as it gets closer, it oscillates back and forth like that. Well, it's actually going to be tighter as it gets closer. So let me try that again. So between 1 and -1. So we might have something that looks like this, and then as it gets closer, it gets tighter and 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 tighter. And then it relaxes again as it goes out. Okay. But something like that where it oscillates a lot back and forth between 1 and -1 as it's close to the value that we're taking the limit of. Okay, so those are the 3 reasons that the limit, as let's say this is x equals 0. So in this case, the limit as x approaches 0 of f of x does not exist.